Problem of the week. There are 5 rocks in a row, and there's a frog sitting on the middle rock. At the end of every minute, this frog will jump to a neighboring rock until it lands on one of the rocks on the end, where it will stay. If the frog is on rock C, then the probability that at the end of that minute it jumps to B is given by this value alpha, which means the probability that it jumps from C to D would be 1 minus alpha. If the frog is on rock B, then the chance that it jumps to A will be beta, and the chance that it jumps back to C will be 1 minus beta. If it's on the rock D, chance that it jumps to E will be gamma, the chance that it jumps back to C will be 1 minus gamma. So the question is to figure out after n minutes what's the probabilities of the rock that the frog will land on. I said that in the worst possible way. So this is like asking 5 different questions. Find the probability that the frog ends up on rock A after n minutes. Find the probability that it ends up on rock B or on C or D or E, right? So I have a little illustration here. I've got my 5 rocks. Our frog is being represented by this blue, round, shiny object. That's a blue, round, shiny frog. And I've picked some probabilities. Here's the chance that it jumps from C to B, chance that it jumps from C to D. There's my beta probabilities and gamma. And then I used a random number generator to produce these decimals here. And if the decimal is less than the probability on the left, then that's the jump I take. If it's greater than, I take the right jump. That's how I'm sort of illustrating this. So let's walk this through. My first random number was 0.48. That is greater than 0.3. So I jump in the greater than direction. Next number was 0.1. That is less than 0.8. So I jump in the less than direction. Next number was 0.33. That's bigger, so I jump back. This frog just gets hopping back and forth between C and D. 0.91. That is bigger than 0.8. And so I jump over here, and that's actually the end of the story. This last number, 0.88, I didn't need it. So in this situation, the frog would have ended up here. But of course, the frog will not always end up in E. The frog will tend to end up at the ends at some point, but it might take a while. So the question is to figure out the probabilities for all 5 rocks after n steps.